Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to discuss about data temperature. Okay, so it might appear strange, but our data, which is basically new oil, it is having temperature. Based on certain properties, we can segregate our data into hot category or cold category. So what are those properties? Let us try to understand in this particular video. And based on this segregation of data based on temperature, how we can design our data pipeline, on that also we are going to discuss few AWS architectures. Okay. So first let us try to understand based on what properties we can say that this data is hot, this data is cold, right? So hot data you can basically consider transactional data. So what is transactional data? I hope already you are familiar with OLTP and OLAP concept. Those data which are generated very recently, like they are newly born, that time those are falling under OLTP category. They are having lesser volume and frequent access is needed. For example, we generally do read, write and update very frequently on this kind of OLTP data, right? So those are kind of transactional data. The important features, as I told you, this data is having high velocity and obviously low volume, because those data are newly generated, not 6 months or 10 months old data. We are considering just 2-3 days old data max to max. So these kind of data, if you consider, they are highly business critical data, right? Generally the graph of data for business criticality follows this pattern, that here if you consider time axis and here this y axis if you consider as business importance, then when the data is generated, that is from the birth of the data, if the time is very less, that time that particular data is having very high business value. Okay, they can impact our business by a very good amount, and eventually with time generally the business importance of the data get decreases. But it is worth mentioning that we can apply data mining and big data analytics on this data to bring business values in the table, right? So this is the general graph. In case of hot data, they are very newly generated kind of transactional data. They are having high velocity and low volume. They are business critical data. So I hope you can understand very easily that it is kind of nothing but OLTP feature. Okay. It need to be stored in some system, some database where read, write and updates that particular database support. Not like OLAP, where in many OLAP warehouse system updates is not supported, right? So that kind of system we cannot use for hot data storage. Okay. And on the opposite side, if you consider cold data, hot data with time become cold data. It is just like any hot substance with time become cold thing. Similarly, following that same pattern, hot data with time become cold data. For example, a data generated just now, it will be falling under hot category. But this same data after 6 months, after 10 months will be converted to cold data. So kind of you can map this particular cold data use cases to OLAP system. Okay, obviously the common feature of the cold data is these are having high volume, petabytes, terabytes of data, and apart from that low velocity. Okay, because here hot data is having a velocity factor, but eventually with time those datasets become historical data and that get converted to cold data. So it is by default having low velocity. Okay. And while storing this old data, we need to keep in mind that we need to choose such system or such database which is comparatively cheaper. Because here huge volume of data we are going to store, right? So if the data warehouse system is costly, then it will bring huge cost for that particular company to store historical data. So always our system should be such that, because hot data need frequent access, it is business critical. So we are okay to pay good amount for hot data storage. Anyway, the hot data is not going to have very huge volume. So for hot data, we can keep little bit costly system for storage purpose. But cold data, because it is historical data, it is having very huge volume. So it should be stored in cheaper place. And by default, we can think like this way also with respect to architecture, that hot data should be stored in such system where the data is easily accessible. The read, write, updates, these kind of operations are happening very frequently, right? So that particular system, database or storage system should support all kind of database operations very quickly. Whereas on the opposite side, cold data can be little slower. Okay, maybe some data warehouse system we can consider, because they don't need frequent access. Maybe for historical analytics purpose or data mining sometime we are accessing, but it is not as frequent as our hot data. Okay, right? So I hope these points you understood with respect to storage or architecture point of view in the data pipeline with respect to hot data and cold data. And here this particular graph basically explaining a very important difference in between hot storage and cold storage. Here if you see this particular diagram where this graph is going like this way, this is basically showing probability of access. Okay. So here this particular axis is suppose time axis. Okay. If you consider hot data or hot region, that is suppose just now the data got generated, that is having very high chance of access. Read, write, update in OLTP system we can frequently do. For example, if you consider Amazon delivery system, if a customer place a order, then for that particular order row, there is a high chance of read, write, update in 2-3 days, right? So probability of access for that particular data in OLTP system is very high. But eventually with time, the probability of access get decreases. So when probability of access is very high, it is kind of falling under hot storage, and eventually we can move that particular data to cold storage once the access probability get decreases. Okay. And here this particular place is showing amount of data, that is this particular graph. Okay. And it is obvious from our previous discussion that hot storage is storing lesser volume of data, past 2-3 days, 5 days data like that, right? So obviously amount of data in the hot storage location is less. But in cold storage, we need to store megabyte, gigabyte, terabyte, petabytes of data, historical data, 5-6 years of data, right? So obviously amount of data in cold storage is very high, right? So I hope intuitively you understood this particular graph also. These concepts are basically helpful in any system design, right? So whenever you are giving interview for D1, 2 or D3 position or senior data engineer, that time these kind of concepts will help you to build a system based on a particular business use case, right? And coming to the next part of our discussion, that how we can map these kind of hot and cold storage concept in big data system design. That let us try to understand. So most of these systems, whatever we build, we need to consider hot storage as well as cold storage. And while storing the data in hot storage, we need to keep these concepts in mind, that the read, write, update should be very frequent, and the database should be such that it will quickly able to do those kind of operations, and it should have no downtime because it is business critical data. And if you consider cold storage, we need to think that very huge volume of data we are going to store, and it should be cheaper. Mostly it will be used for analytical purpose. And we need to think this point also, that our big data pipeline should be such that eventually the hot data will move to cold data. Okay, so one such architecture is shown here. Let us try to explore from beginning. Okay, so let's consider temperature sensor data. If you think with respect to just now what I discussed, any temperature sensor data, whatever temperature it is capturing, if the data is captured just now, it is having its maximum significance, right? Maybe some weather prediction or something we can do quickly on that recent data, right? So that will be falling under hot zone. But suppose 6-7 months old temperature data you are having, that is having lesser importance. So that time we need to eventually move that particular row which is generated before 6-7 months, that eventually we should move to cold storage, right? So how that is happening, let us try to understand. So here we are having our temperature sensor. It is capturing the current temperature and it is putting in some data streaming system. Here we are using Kinesis data stream. Okay. Now here we need to save this particular data in some database where we can easily frequently access, read, write, updates, this kind of operation we can do. So for that, one such system is DynamoDB. So if from Kinesis data stream, we can trigger our Lambda and Lambda can write that data in DynamoDB. Okay. So these become our hot storage. Okay. First location. Now suppose the temperature sensor has captured the data and it's now 6-7 month old data stored in DynamoDB. That particular data is having lesser significance. So better if we can move that particular data in some cheaper location, right? Instead of storing in DynamoDB. So that time the TTL feature can help us. What is TTL? On this I have already discussed in my previous video. I'll be sharing the link in the description box. You can check there. Basically, it is nothing but a feature of DynamoDB where what we do while storing that particular row in DynamoDB, we configure a time at which that particular data can be expired. And based on that particular time, DynamoDB will automatically delete that particular data from this table. Okay. And now that hot data became cold after 6-7 months, but I don't want to completely delete from my system. I want to store in cold storage, right? Now from hot storage, when the data is getting deleted, what we can do using DynamoDB stream, we can quickly catch that in Kinesis data stream. And from there, we can share that particular data to Firehose, and Firehose can flush that data in partition format in our S3 data lake. Okay, and now suppose some OLAP computation for past 3-4 months data if you want to do, that time what we can do? From S3 we need some SQL engine. So one simple way for ad hoc analytics we can do, we can create a crawler, we can run the crawler and it will be creating a catalog table. That catalog table we can easily access using Athena. From Athena we can create quick site data visualization for our business team for OLAP purpose. Okay, or the second option can be, suppose on that temperature sensor data we need to do certain big data computation, then we can use PySpark in EMR, and then processed data we can publish in S3 publish layer, that is another S3 location. From there we can store that data in some cloud warehousing system like Redshift or Snowflake, and from there we can build the data visualization for our business users using Tableau. Okay, and they can access that, right? So using this particular data pipeline, I hope you are getting it, that initially our data is getting landed in hot storage, but eventually it is getting moved to cold storage. This Snowflake, S3, Athena, these are coming under cold category. They are comparatively cheaper to store huge volume of data, and in DynamoDB we are storing our hot data, right? So this is one of the sample architecture where both hot storage and cold storage are implemented in such a way that it will be a robust architecture, and automatically hot data, when it will be converted to cold data from hot storage, it will be automatically migrating to cold storage, right? Another example, let me show you, and this is from AWS. This is my architecture videos. So here this particular company is helping their client in ensuring safe vessel transit at seaports with data. Okay, let's not go deep into the business aspect. Let's try to understand how they have maintained that hot storage and cold storage separation, and how eventually they are moving their hot data to cold storage, right? So here port sensor we are having, like earlier we are having temperature sensor. So similarly here port sensor is having, it is capturing information related to that port, maybe the wind speed, maybe the sea level, maybe the temperature or something like that sort of information. And then what they are doing, they are publishing that data in MSK. Okay, what is MSK? MSK is nothing but managed streaming for Apache Kafka. On this I have created a complete playlist covering all the important features of MSK. You can check the link given in the description box to explore more about MSK. Now the data is MSK, it is nothing but a Kafka, and Kafka is used for real time, that we know. So it is giving us a feeling of OLTP, online transactional processing. So we understood this part, that our hot data is getting stored in Kafka. Now if you don't consider the rest part, how you can move the Kafka data in some cold storage, just try to think for a second. So one simple option can be Kafka Connect, right? A better way I can say, using sync Kafka connector, the data it will read from a particular topic and it can write in our S3 data lake, right? So that sync connector we can incorporate in our this architecture to move our hot data to cold after a few months if we want. But that might not be a very good choice, because you think like this way, sync connector generally works as soon as data comes in Kafka, it will try to push in S3. But suppose the business want that immediately it don't want to put that data in cold storage. First it only want to move that data in some hot storage, and then eventually it should be moved to cold storage. That kind of approach business team want to follow. Or maybe for example, you can consider that business team want to get some data by applying some SQL query. Now on Kafka directly applying SQL query is little difficult. So better if we can store this Kafka data in some sort of OLTP system or hot storage, that will be helpful in that case, right? So let us try to understand how that is done here. So here initially what they are doing, from port sensor, the data is getting ingested in MSK. From MSK, we are using MSK Lambda trigger. This particular feature I have already discussed, that AWS Lambda function you can directly trigger as soon as some message lands in a particular topic, right? This Lambda is getting triggered by that particular event, whatever is getting published in MSK, and it is writing that particular data in some DynamoDB table. And obviously, again, that same point, that while storing the data in DynamoDB table, we need to configure TTL so that after 6-7 months or after a certain time, the data can be expired from this hot storage and it can be moved to cold storage. Okay, right? Now from this DynamoDB table, what we are doing based on TTL feature when it is getting expired, using DynamoDB stream via Kinesis stream, we are ingesting that data in Firehose. Okay. Now from Firehose, we are basically storing that data in S3 data lake. So this become our cold storage. And this is our hot storage. Right? So I hope you are getting it, that if your system is Kafka in the front side of your data pipeline, then how to move the data from hot to cold storage. I hope this particular part is clear to you. And what this particular section is doing, so they are basically helping some user to fetch some data. Maybe here business users is asking for some data. So they have created one API for that, and that API gateway backend is supported by Lambda. And whenever user is making some request, maybe that is hot data or that can be cold data, that request is basically getting to this Lambda. That is our Lambda is getting triggered based on this Amazon API gateway event, and that Lambda is deciding where it need to go. If it is hot storage, it is going to our DynamoDB to fetch that particular data, and if the data is very old data, that means if the data is old data, then the Lambda will understand, okay, I will not get that data in DynamoDB, so I need to scan in S3, and the best way to scan in S3 is using Amazon Athena. So the Lambda is basically that time for cold data, it is executing using Athena, and whatever result it is getting, that it is sending to that user via this particular route. Okay, so this particular part here I can highlight using some other color. So this particular part is basically nothing but acting as a data provider for their pipeline. Okay, and here we are having ECS also. Maybe that particular ECS is helping in some kind of predictive analytics purpose. From this S3 historical data, that is from our data lake where all the past data is stored, it is reading, it is doing some sort of data mining, and the prediction information it is writing in some other S3 location. So this particular part again is a separate section. Okay. So here I hope this particular pipeline is also giving you some sense on building a data pipeline where both hot data, cold data, hot storage, cold storage is maintained. And this particular video link and some more reference articles I'll be sharing in the description box, from where you will get a very good strong foundation on this kind of data temperature related architecture. This is all for this video. If you find this video helpful, then please like, share and comment, subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.